SCSI and Ultra DMA, again, Small Computer Systems Interface is what SCSI stands for, and Ultra DMA, so Direct Memory Access IDE, Integrated Device Comparisons. So we have Feature, SCSI, and then Ultra DMA IDE. Devices per channel, so in the SCSI you have 7 to 15 per chain, and then the Ultra DMA IDE was 2 per chain. Remember, we had 2 slots, master and slave. The closest you are to the motherboard is the master. We had connection types, internal and external. Remember, we can attach the SATA, SAS drives externally and then down to a complete chassis, right, where all the drives are stored. So inside the little pizza box server, there are no hard drives, which are noisy, they need a lot of air, so that's what you see those 4 U chassis for, the big thick ones. So picture 4 pizza boxes stacked on top of each other. That's the drive chassis. So if you're looking at a rack and you see a bunch of 4 stacked pizza boxes down below, 1, 2, 4, 8, 12, 16, however many you have, they're going to be SAS drives connected to each other in real life up to the pizza box controller. And it could be a long pizza box or it could be a half, like literally a square pizza box. Sometimes the chassis, the main control servers will be 2 pizza boxes put together. That's about how big they are. True bus mastering. The Ultra DMA did not do it. The SCSI does. Operate more than 1 I/O device at a time. SCSI, yes. Ultra DMA, IDE, no. So if you're copying from the CD-ROM to the hard drive on the same ribbon, that was a problem, right? So what you would want to do is put your hard drives on the first ribbon, and then the optical drives on the second ribbon, and then they could write faster that way. Because otherwise you got to read it in and then write it back out. It would not go directly. It had to go through the motherboard, through the DMA. It has to go to the memory. And then operate more than 1 device at a time. We talked about that. And then advanced commands, yes for SCSI, no for Ultra DMA. Noise and small computer systems interfaces. Any electrical signal other than data is noise. Even in electrical signals, there's a noise floor. So this is your noise floor. Up to here is noise. So your signals have to be stronger than the noise level to get noticed, right? If the noise floor is above your signal power or very close to it, you won't be able to hear each other. I like to use a cocktail party analogy. If you're at a cocktail party, multiple people are talking, I'm going to have to speak louder so that I can get above their voices. If we're all talking at the same level, it's going to be noise. You won't be able to understand me. So that's what the noise floor is about. Every communication signal has a noise floor, and you have to have enough power to get above that floor. And then if you have noise that gets induced and then kind of goes away, but at some level there's always this amount of noise no matter what, from infrared, from light, from the sun, from everything, all the energy around you. So noise is spread through power cables is a common mode noise. So there's a common mode noise, that's noise from the power supply through the power cable. Then we have single-ended devices are vulnerable to common mode noise, single-ended. And then differential-ended devices reject common mode noise. So differential, they use some different technology to see the noise, and then they can reject it. And the way they do it is if you have noise up to here, then I create noise up to here. When you combine the two, they cancel each other out. So it kills the noise floor. Troubleshooting a device conflict. We talked about setting the jumpers and things like that on the SCSI, on the IDE cables, the master-slave. If you have a conflict, we're going to load only device drivers for the SCSI device. So we're talking about specifically SCSI device troubleshooting here. Load only device drivers for the SCSI device. Use the F8 key to load the driver. And that's when Windows was rebooting the older versions, you could do that. And then try the / option with the device driver executable to see what the options are that you can feed it. Look in the device documentation, find the latest drivers. If no solution works, choose between the multiple devices or go to a multiple boot configuration. So in this boot configuration, I'm using this device. In this boot configuration, I'm using that device. So you need to know this for the test. You'll have a couple of test questions that come out of here. Costs and benefits of the SCSI, Small Computer Systems Interface. The devices and the technology cost more than IDE. The cost may be justified in certain high-end environments, like scanning huge giant documents, plotter scanners, that kind of thing. SCSI was very fast and worth it at the time. Because in commercial, you need to be able to scan 4 or 5 plots per customer, right? So you don't want them sitting there waiting on each other forever. Setting up a SCSI subsystem, install the host adapter, set the SCSI IDs, where they're at in the chain, and then connect them accordingly. Terminating and cabling, power up one device at a time and check for problems, load the operating system drivers and SCSI software. Most of the latest stuff would just plug and play. You didn't really have any big issues with it. The host adapter is typically set to 7. There is no mandated order. The host adapter manufacturer may represent the ID or may preset the ID. This was pretty common and this worked. So the logical unit number, or the LUN, is used to support more than one device per ID. So you might have the same manufacturer's ID, but they use the LUN to distinguish between the two. Termination of the SCSI. So termination prevents signal reflection, so it goes down and starts reflecting back and then causing issues. Newer SCSI devices use active termination. Older SCSI devices use passive termination. So termination is typically built in, but some devices require manual termination. Both ends of the chain must be terminated, and devices in between must not be terminated. Most new SCSI devices set termination automatically, and this was true. The early ones you had to set it. Like you might have a scanner with jumpers in the back like you saw in the little hard drive pictures earlier. So in summary, CD-ROMs provide durable, removable storage for archiving. Newer CD-ROM technologies provide multimedia support, audio, video, that kind of stuff, instead of just data. And then DVD is an extension of a CD-ROM technology. Of course, it's an optical disc. And then DVD can be used to store multiple formats. Yes, there are many, many formats they supported, as well as CD-ROMs. They had many formats as well. Enhanced IDE and Ultra DMA IDE drives solve earlier drive issues, speed issues, compatibility issues, and then SCSI drives offer performance and reliability benefits, and they were a lot faster. That's what they get at by performance.